Okay, so time to see what DB48X version 0.4.8 can do for you. And so that was released about 2 days ago. And you'll see that this is already a pretty decent calculator. So I'm going to test it on DM42, DM32, and I'm going also to show the same thing on a simulator, which has the benefit that when I hit a key, you see it highlighted so you know what I'm typing exactly. And it also shows the precise layout that is intended for the software. There is an overlay that you can see here on the DM32. I did not put the stickers on the keys, so some of the original key markings are incorrect in the DM32. 1/x is at the wrong spot compared to, because that's 1/x in DB48X, which is correct for the DM42. Usually, or overall, you can use the DM42 with DB48X practically without an overlay. It's much more difficult for the DM32. There is a link in the documentation for the project on where to get the overlay. So let's start by entering numbers. So you enter numbers the usual way. Enter to finish the entry of a number. That's an RPN or RPL machine. Then I can add 3, and I can subtract 5, multiply by 398. So far, the only thing that might surprise you is that the numbers are shown with separators. This is also true when you type them on the command line. This was a feature of the HP17B, I think, and other financial calculators. And one of the early users of DB48X really loved that feature and asked me to implement that. So the arithmetic on integers is really very usual. You have the change of sign. You can also change sign while you're entering the numbers. So the first thing that might surprise you is that if you do, for instance, 1 divided by 3, you don't get 0.3333, you get 1/3. So it keeps the exact equation. The objective is to stay as accurate as possible for as long as possible. So there is an internal representation for fractions, and the calculator knows how to do operations on fractions, including adding them and so on. So you can multiply fractions and so on. Another thing that you might have noticed from the examples I'm showing here is that I can deal with fairly large numbers. And if my numbers grow too big, if my numbers grow too big, then they are going to show up like this on multiple line. I'm going to multiply it again. Only the result is shown like this on multiple lines. The second level of the stack is showing with a ... notation indicating that it overflows, and it shows you the beginning and the end of the number. If the number is really too big for things to show on screen, like for instance, if I compute 2 to the 100th power, which is going to take a little bit of time, then you see that you have this ... notation in the middle that tells you that it's running out of space to display it. Now, if you want to have the details about that number, you simply hit the down key, and that brings it in the text editor, and then you can scroll through it like this to see all the digits in your number. As you can see, with a number that big, the calculator is not super powerful, and so you might actually end up having to wait. Now, this is not a limitation of the system. I can compute the same thing on the simulator, which runs on a real computer, and you're going to see that operations are completely instantaneous there. So if someday we have more powerful CPUs in the calculators, we are going to be able to do computations on very large numbers. Now you have a number of built-in functions. So not very surprisingly, if I hit, for instance, 1 over x, that gives me a fraction, 1/13. So you have seen that we have separators for very large numbers that make them more readable. If I enter a decimal point and I enter more digits like this, I will also have separators, but they are every 5 digits for the fractional part. So this is configurable. You can really set things up the way you want. You can change the separator character and how many digits separate for the whole part and for the decimal part. So we have a very large number of functions on this calculator. And one of the big problems that we have is that while it's easy to have a function like 1 over x, we need to have more features. And HP has always solved this problem by having shift keys. So you have, for instance, on the HP48, you have a right shift key in blue, a left shift key in yellow, an alpha key for alpha entry, and a space key. And all these keys are missing on the GM42, so we need to have replacement for them. So the first function, the hint is on the overlay here. You should really use an overlay if you're using the GM32 because the keys don't have the same layout and it's really not convenient. With the GM42, you can sort of, the placement of most of the features is really close. You see the complex menu is where the complex menu is on the GM42 and so on. So you can use the GM42 practically without an overlay. It's much more difficult with the GM32, but the website indicates where you can find the overlay. Now, if you want to have extra functions, so the hint is here that if you press once, you get, you see in the annotator area, a little character that looks like this character here, like this sign. And if I hit shift twice, then it's a right shift, and it's going to invoke the functions in blue on the overlay. So let me give an example of first shifted function with the square. So I've computed the square of my fraction. And a very convenient second shifted function is the help function, which is on the plus key. So you see the plus help there. So if I hit 1 shift, 2 shift plus, and that brings me an overview of the calculator, which is exactly the same content that you will find here, including all the hyperlinks. And so for instance, I'm presently following the quick start guide here. We are going to follow that on the calculator, and you see that I can go to the next link with the F3 key. Sorry, that was page down. Sorry, that's next. Previous link is F4, and next link is F5. So if I want to select a link, enter, and I go to the quick start guide, and then there are instructions on how to install things, etc., which are very incomplete. If you want to help the project, helping with the documentation is one way to go. Now, there is a back topic entry here on F6 that lets me go back to the previous topic. And there is, I can do the same thing with the back key, backspace here, and that does the same thing. All this is explained in using the online help, which you see here, and you can see it rendered on the calculator. Oops, what did I do? I think I hit the quick start guide. So you see the online help, the same content. So one difference is the rendering, for instance, of the arrow key, of the shift keys, where the marking corresponds to what is shown on the screen, but it's displayed on the web as a blue key instead. So I'm going to use the simulator for many operations. because the simulator shows you the keys that I'm typing when I type them. So if I type 1, 2, 3, you can see the exact keys that I typed. And so if you watch the video slowly, that will help you know what I'm doing. And so one of the interesting ways to access the online help, which I'm going to illustrate first on the simulator, is with plus, and I showed that to you. So if I hit right shift plus, that's the help marking that you see here, and that invokes the online help. Now this is contextual, so if I leave the help with exit and I enter a number, for instance, and I hit help, then it's going to give me help about integers. And if instead I have a decimal number and I hit help, it gives me help about decimal numbers. So it gives you the precision and all this kind of information. So this is very convenient. There is another way. If you have used an HP41 calculator, for instance, you may remember that when you hit a function, the name of the function is shown on the screen. So if I hit sin, it shows the sin function name. And on the HP41, when you hit that key and keep it held, it cancels the function. On DB48X, it cancels the function as well, but it shows the online help for that function. And so that means you can really easily find documentation about all the many functions. So for instance, if there is a hyperbolic function here with second shift hip, and I want to have help about the hyperbolic cosine. So the help is not very fleshed out for the moment, but you get the idea on how to access the many features. Some topics are better documented, and again, that's one area where I would really like to have help from the community. The annotator area where we have the shift functions also contains information about the battery level. So this calculator is on battery, and you see the battery level remaining along with the voltage. A calculator that is connected has this area grayed out to say that it's not losing battery power. And you have also information. You have the date, the time, the current time, etc. This can be configured in the setup menu, shift setup, shift setup. And if you look at the status bar, that's 4. So I'm going to select that, and you select the various options there. So this is very similar to how it's done for the GM42. Right now, you can essentially configure the status bar with fixed menus in a way similar to the GM42. However, keeping in the spirit of the HP48, it's likely that in the future, you will be able to configure that the way you want using RPL. The demo name that you see that there is the name of the state file that you can also access with the setup menu, just like on the GM42. So this means that you can change between multiple states for the whole system. Okay, so let's try to enter decimal numbers now. So it's really the usual way. 1.25 gives me a decimal number. I can enter scientific notation with times 10 to the power of n on the simulator. That's next to the O key, and that's next to the E key on the GM32 and GM42. So for instance, I can enter 1000 that way, and so for instance 1.25 million that way. Nothing very surprising here. What is interesting though is that well, first of all, it's necessary to say that the arithmetic on these numbers is highly precise. It uses the same engine as on the DB48, so it's a 128-bit binary decimal that gives you 34 digits of actual precision, which is quite a bit. And you can, of course, adjust the display, but the computations internally are all done on 34 digits. So when you have a number like this, you can use EEX to cycle between the fraction and the whole number representation. And so, for instance, if I have I add 1 to this, I'm going to have this representation, and I hit the EEX key, and I'm going to have the fractional representation. Now, this is a difference compared to the HP calculators, where when you hit the EEX key without doing anything, it enters 1E at the beginning. So if you're really familiar with that, that's the difference in the user interface. But we don't have too many keys, and we have to make various trade-offs. And I think that's a good one. So if you enter a really big number like this, you're going to see that the separator for the fractional part is at a different spot. So it's every 5 digits for the fractional part and every 3 digits for the whole part. And this is being live as well during editing. This is a feature request from one of my very early users who loved that feature from the financial calculators. I think the HP17B had this behavior. And so while you're live editing the numbers, it's going to maintain this digit grouping as well. So it's very convenient to enter big numbers. Okay, so one of the features that we very quickly saw earlier is soft keys and soft menus. So you have all these soft keys here, and when you hit some functions, you're going to see menus that correspond to that. So in the case of DB48X, so what I'm showing here is the disk menu, and that's the menu used to select the number of decimals and things like that. So let's compute 1/3 and switch to decimal and shift to this menu over here. So first of all, the menus can have up to 18 functions for the 6 keys that correspond to shift, second shift, and no shift. So in the case of the display menu, that's essentially the standard display modes that you are probably familiar with if you've used HP calculators before. So if I use fix 4, for instance, 4 and then hitting the F2 key, and you see the menu changes to fix 4, and it only displays 4 digits after the decimal sign. The scientific notation uses an exponent always. So if I use force SCI of, let's use 5 to make a change, then I have 5 digits and an exponent. And the Eng mode, also inherited from HP, is the same thing, but with only powers of 3. So you see that now this is displayed as 333 to the power times 10 to the power minus 3. A new one that doesn't exist on HP is SIG. So what SIG does is that it lets you display numbers with a limited precision, but without adding the trailing zeros. So let me use SIG5 now, SIG2, sorry. So that means 2 significant digits. So in that case, the 2 digits are 3 and 3. And if I multiply this by 10, it's going to show like this. So what is interesting is what happens if you have a large SIG, like for instance 12 SIG simulates what the HP48's standard mode is. If I display 1, 2, 3, it's going to show like this. But if I take the sign of this, I'm going to have only 12 digits. So it essentially simulates the 12-digit precision of the HP calculator. There are other more subtle settings. For instance, I can change the fractional part. So let me have a number like this, and I multiply that by 10,000. And you see that I have the 3 digits on the left. I can change that by setting the mantissa shift F1, and now it's separated every 2 digits. And if I use, for instance, 4 for the fractional part, like this, let me multiply that by 10 once more, and so the digit grouping for the value 2 seems to be bogus. It's interesting. So I'll check why it behaves that way. It's separated every other 2, but it should start with the first lower 2. And you can change the separators. So this is the F6 menu. For instance, some countries would use commas as a separator. Some countries would use ticks. Some engineers would prefer to use an underscore. And of course, between France, Europe, and well, most of Europe actually uses a comma as a digit separator instead of a dot. So all this can be set up this way. So in terms of scientific functions, they are very easily accessible, just like on the DM42. So for instance, sine, cos, and tangent are fairly easy accessible like this. Now there is a really interesting difference, which is the location of the exp and log keys. So I thought it was more useful to have 2 complementary functions for the log and the exponential. So if I do 1 and I get the exponential, but you see that this does not correspond to the key neither on the DM32, where the exp is over there, 32, sorry, where the exp is over there, nor on the DM42, where the exp is shifted. So compared to the DM42, it's the exp and the log are shifted. So this was more useful that way. So depending on where you're looking for a function, you might find it either as a shifted function for things that are really frequent. Like for instance, if I want to have the arc sine of 0.5, I shift sine and I get this. So I'm running in degrees at the moment. You can change that, of course. If you want something slightly more sophisticated, like hyperbolic cosine, that would be second shift J, and that's a menu, and I can use, for instance, the hyperbolic cosine that way. So because this is RPL, the stack is not limited to 4 levels. So this means that I have a practically infinite stack. And even if it runs out of the screen, like this is the case now, this is still remembered by the calculator. So if I drop things with backspace, I'm going to retrieve my other values. So one thing that is different, I mentioned that earlier, is that the first level of the stack is called the result, and it's shown with slightly different properties. That's where you can have the possibility to show it on multiple lines. So if the result is really big, that's going to show on multiple lines like this. But you can also select a different font for that, and you can have a different font size for the first and second level. So we are going to see that with going back to the disk menu. And now I'm going to select UI. So that's F5. second shift, and now I can select the size for the result, and you see result shows as 1 and stack shows as 1 as well. But if I say now 2 for stack, that's a smaller font for the rest of the stack. So this is really a personal preference. Since I'm doing a demo here, I'm going to prefer to use a larger font for the stack, and you can use an even larger font for the results if you prefer to have the results show as big as in the text editor. So let me get back to the default settings. So we saw that a number that is really too big gets truncated, but the stack itself is not truncated. And so we are going to use that properties to see this computation from a venerable manual for the HP67. That's page 106. And there is this really complicated expression that is computed in the middle. And so we are going to try to enter that and see how not having a limitation on the stack size really helps. Because whereas the manual here tells you to start with the innermost brackets, and that's because otherwise you would run out of stack, with RPL you can just go straight ahead and do the computation. So I start by entering 5 because I have a 5 on the left, then I have a 1, then I have a 0.2, then I have 350 divided by 61.5. So I do this division now, and I need to square that. And then I multiply by 0.2. Now, I could have made a mistake on 0.2, and if that was the case, I would see now that 0.2 was out of place. So let's show how to correct a mistake. I can swap and drop that and enter another value. In my case, I'm going to enter my value and then swap again. And I can do my multiplication now. I add 1. And then this is to the power 350, 3.5. I subtract 1. Then there is this other element. So you saw that we already exceeded the 4th level of the stack, but I did not have to mind. 16875 to the power minus 6, 25,500 times minus, and this is to the power 5.2, that seems to be 2656, 2656, and negative power of that, and I multiply the 2, I add 1, and 0.286, power of that minus 1. I multiply by 5, the 5 that I had at the beginning, and I take the square root, and that's the C key. And I see that I get what appears to be the correct results with more digits than what was given by the HP67 example. So this is somewhat convenient because you really can do numbers, enter operation relatively easily. Now we are going to see in a moment that you can also do that with the algebraic notation. That's one of the big things that RPL has. So you can use that to accelerate computations as well. Now, when you have a result like this, having an infinite stack means that you can easily duplicate it like this to save it for later, and you can drop the results with drop, which is the backspace key. But there's also a last args operation, so that's mapped on the corresponding to last x on the DM42 and DM32. So for instance, let's say that I multiply these two numbers. And if I do last now, so that's shift, I have both arguments. So it's not like RPN where you get only last x. In the case of RPL, you get the last two arguments. And now, for instance, I can divide them instead of multiplying. So I can compare a result of various operations on the same input. Now, if you do another mistake, so let's say you do this and you multiply and you wanted to divide, well, there is also a second shift with the swap key. That is the undo. It's the last stack. And so that lets you get the correct stack state, and then you can, for instance, add. So we already saw that we can edit an object by using the right key, and that brings it to the editor. What we have not seen yet is that there is an edit menu that is on second shift and the right key, and that gives me features like being able to move one word to the right or one word to the left. And so I can move through my big number faster that way. I can move directly to the end of the buffer with using shift, or to the beginning. And what is also interesting is that I can select text. So I hit F1 and then I select a piece of text like this. And I can, for instance, cut it like on a computer and paste it back. So just like on your computer. Now, you see this Shift F1 is swapping cursor and selection. And we are going to see that this is a good way to move between two locations in your editor. And there is also a search feature. So for instance, let's see if we have multiple instances of, oops. So let me show the history feature. So second shift up, and I'll get back my editor. So if I hit exit by mistake, I can go back. So let me check if I see another 6. So I select, and then I move right like this, and I hit 4 for search. And it's going to search other instances of that. Okay, do we have the sequence 226 like this? So I just move with my arrows and then hit search, and I can find the other instances. And that's where the shifting the cursor and selection is useful, because in that case, the search goes backwards. So this is mostly useful when you're programming. When you end the search with enter, and now I can enter my number. Okay, because I pasted, now there are too many digits, and that's an error on DB48X. It complains if there are too many digits in a number, because it loses precision. So if I have something that is a little bit more complicated in terms of text, we are going to type version, and that gives us the version that we are currently running. This is a simulator that I use for development, so this is not the regular 0.4.8. And you see that I can move like this the same way. My selection works the same. But now I have shift up and shift. Now all these keys have auto repeat, so I can repeat down and repeat up that way. So this is worth checking on a real calculator so that you can see the speed on a real machine. Let's type, for instance, version again. So and that's the text editor on a physical machine. So you see that it's reasonably fast. And when you do, so what I wanted to show is that when you do a search there, the search is incremental in alphabetic mode. The alpha mode appears here. And if I type, for instance, let's say MO, sorry, where is the MO? You see that it finds modern, and I can find that there is nothing else. You can also hear the beep that you don't hear on the simulator. So this is incremental search for things that were not already in your text. You can simply type what you're looking for. So this is for the editor. We have very quickly seen the command line history. And so this is invoked by selecting second shift history here. And if I do that again, then it's going to give me things that I had in the command line before. And there are 8 entries in the history like this. Now we have very quickly seen how I typed version, and you may wonder how I've done that. So another key that is missing but is very important on the HP48 is this infamous alpha key, and that's for alphabetic entry. And that's something that is really useful on RPL. So there are multiple ways to enter to enter alphabetic characters. The alphabetic characters are marked on the right of the keys. So the first method is to hold the shift key, and then the cursor changes to ABC, and then I can type ABC. So all the crashes that you see on the 32, on the 32 is because I just realized I uploaded a version that doesn't have a fix regarding fonts. That has been fixed since then. So it's using 42 font on a 32, which is the root cause for the crashes. So let me shift back to the 32. I think you should not see that in 049. You might hit it on 048, but I think you won't hit it on 049. I hold alpha like this, and I see the indicator shift to alpha, and then I can enter alphabetic characters like this. Another method to enter alpha is to use shift and alpha, and that brings me the alpha mode. The difference here is that if I hit shift alpha a second time, then I get lower cases. And so that lets me type a mix of uppercase and lowercase. And there is a third way, which is to hold the up for uppercase or down for lowercase key while you hit the key, but you have to do that quickly, otherwise it's interpreted as an arrow key. So if I do Shift A, for instance, I get an A. And once you have started typing, you don't need to be fast. It's only the first one has to be fast. So you have to think about the first one you type, and for lowercase, it's like this. So that's really a very handy shortcut. Down and X are really close. So if you want to enter an X variable or a Y variable, that's very quick. You can practically do it with a single finger. So I typed the command earlier. I typed the version command, and you can essentially type any command that way. And what you see there is a cursor that shows D, and D means direct. That means if I hit enter, it's going to evaluate that function and do it for me. I can, for instance, execute a sign that way. I type a space, so you may have seen that the space is on this key, is the RS key here. So same location as on the HP48. And now I can type, for instance, the name of an actual function. So in that case, I'm going to use the sine function. So S, Y, N, and if I hit enter, I get the same result as if I had hit the key. It's calling the same function. Now, when you are in alpha mode, so I use the alpha mode that way, you can see that the cursor turns white. And the cursor changes shape and the letter inside changes depending on what you're doing. So we are going to see more examples of this. But the white indicates that you're entering alpha. And so now I can also type more slowly. I take my time, S, Y, N. Now, there is a really, really handy feature when I'm in alpha mode, is that I can use the plus key. And the plus key calls a catalog that gives me all the functions that begin with this sin. And if I had only S, I would have a change of sign, same, etc. And if I type the I, then I have only things that can begin with SI. And if I type N, all the things that contain the sign string. So that's a good way to enter a function among many without remembering where the menu is. Now, what happens if I enter a name that doesn't exist as a function? Well, that was the case with X, and that gives me a name. So that's a symbol. And in RPL, these are used, for instance, to name variables. And this was the case for the ABC that we had there. That was a name. So we have seen that the cursor can change, and we are going to see that more with the version that we were using earlier. So VE for version, and now you know that I can type plus, and I get my version that way. And I bring the editor like this, and you see that if I move forward one character, this changes from D to L. And that tells me that I'm inside text now. And there are a number of features that are going to behave differently if I'm inside an object, and based on the object, it's going to change the behavior of some keys. So the L here stands for lowercase, and if I hit alpha, I am going to see an uppercase C and lowercase here, but now it's white, telling me that I'm in alpha mode. So what happens when I use second shift with alpha? Then I have these quotation marks there, and you see that the text is white already, and I already have ABC. The cursor is white already. So this means that I'm entering in alpha mode, and I'm actually entering text. And that's for arbitrary text. And the version string that we saw earlier was just text. Now, unlike, for instance, the HP41, the text can be as big as you want, and it's just like another object, and I can do operations on it. Like, for instance, I can add a text to another text. So I can use DEF, and if I add the two, I have ABCDEF. But this behaves like any other object on the stack, so I can swap just like I would for numbers, and I can add ABC again. I can even do mixed operations, like for instance, I can add this. So let me add something first. Let me edit, and I'm going to use the overlay here as a reminder that I need to be in alpha mode and to shift cost to have equal. And then I can have 2.5, 2.2 plus, and I've added the 2, and that's a good way to have a label that displays something. I can also do an operation like multiplying a text by a number, and that's essentially repeating the same text a number of times. So if I want to have A repeated 80 times, that's as simple as that. Now, another thing that you saw maybe with the name is that it had this little quotation mark around it. Now, the quotation mark key is this key, and that can be used to enter our algebraic expression. For instance, I can do this. And then in that case, this is equivalent to equal. That's going to compute the result. So that lets me enter non-RPN expressions very quickly. You can remember on the DiEM42, you can remember that as execute equation or something like that. So let me do this. I'm going to do 1 plus 2 times 3. And then I can evaluate that just like this. But I can also perform operations on it. And the calculator is smart enough to compute directly on this object. So for instance, I can multiply this by 9. And I'm going to have an expression. I can even have expressions that contain names in them, like this. So now I have an equation that, or an expression that evaluates a value. And if I evaluate this, it's going to evaluate what it can and stop what it cannot. So you really, like on the HP48, you can mix between RPN and algebraic fairly easily. And that's really convenient in practice. There are a number of automatic simplifications in that case. So for instance, if I multiply that by 1, it's going to give me the same result. Smarter yet, if I add 0, it adds nothing. And if I multiply by 0, I get 0. So there are a number of simplifications like this. There is a flag that controls that, so you can decide to do it or not. So there are many, many menus, and one problem is to find the right one for what you're doing. So we saw that the help was contextual, but there is another contextual key called the tool key. So you see this special symbol here, and that does something that depends on what you're doing. By default, it brings a general menu that gives you a quick access to practically all the features in the calculator, beginnings with the help. So that's another way to get the help. But if you have, for instance, an integer on the stack and you use that, you're going to have a menu for operations on integers and real numbers. If you have text and you use the tool menu, you're going to see that it doesn't detect text yet. I forgot about that. Yeah, the text menu is practically empty. So the text menu at the moment is over there, and it's practically doing nothing. So it's not connected yet to the tools menu. But that's a good reminder that I need to do that. If I use an expression like, so let me, oops. Let me enter x plus y. And if I use tools menu, it's going to show me operations that apply on expressions. Okay, so let's do more advanced math. One of the interesting features, so let's return to the simulator for that. And so one of the interesting features that RPL made much simpler than what you can find in calculators like the DiEM42 or the HP15 or whatever is handling complex numbers. So complex numbers on the DB48X are dealt with using the complex menu, which is Shift-Stow. And I can enter a number in polar form like this, sorry, rectangular form like this, or in polar form like that. So in that case, I'm using degrees because that's the angle mode. So let me do this on the simulator as well. So let me, for instance, have 2 plus I, and I'm going to set it to its own power. So I just do the usual operation, and that's the result I get. So again, this is subject to the fixed menu. So if I find it inconvenient to have multiple lines for that, I can select the disk menu and go to fix 4, for instance, or std4, so seek4 would be fine. And now I have numbers in a more reasonable way for the display. So you have seen that the complex menu lets me enter things both in polar and in rectangular form. So as far as possible, the calculator is trying to keep the values in the most efficient way for the computation you do. So let's say you have 1 plus 2i and 3 plus 4i, and you add this. The result is also in polar form. And just like for other computations, the real and fractional part can be equations. So it can be fractions, but they can also be equations. So I can, for instance, do this. I enter so a plus ib, and I multiply that by the above, and I get a symbolic result with a part for the real part and the imaginary part. So let me isolate, for instance, the real part of that. And I swap. Oops. And let me isolate the imaginary part. I can also enter values in polar form. So these are sometimes called phasors. So for instance, that would be 10i in phasor form. And if I multiply it, so that's 10 times I, and I square it, I'm going to have so y square. I'm going to have exact results again. So I can have fractions again. Now what is interesting is that the phase is stored as a fraction of pi, which can be an exact fraction. And so that leads to interesting operations, like for instance, if I have 2 with an angle of 45 degrees, and I multiply this by 3 with an angle of, let's say, 90 degrees. And I get this. And now if I take this to the 8th power, like this, and you see that I get an exact number. And there is no approximation there. And if you do the same calculation on the HP50G, for instance, you get something like 001 because it's doing various approximations at various steps. So you get much better precision like this. And of course, the usual functions work on complex numbers, like you can compute the sine or so this is not a very good example because this was actually a real number, but I can do, for instance, so zero plus 1i, and I'm going to do an exponential of that. Yeah, that's 1 radian. So if I convert that to radians, I was surprised for a moment because the result is in degrees and that the exp works in radians. So the angle mode impacts how you display the polar form. Let me shift that with the modes menu. That's the modes menu, if I display that as radians, I get the expected result. And that's a fraction of pi. And the last mode is grads, which, as far as I know, nobody uses. So you can also enter vectors. So to enter vectors, you use the Shift 9 key. And so let me do that right now. Shift 9 like this. And I can enter a vector. So that's where the space key is really useful. So I enter 1, 2, 3, and then I can enter 4, 5, 6, and I can add these two vectors. And as usual, the results are exact and they can involve, for instance, complex numbers. When I'm entering a vector, you can see that the cursor changes to M, and again, there are some subtle changes in behavior when you are in matrix mode like this. So if I multiply two vectors, it's going to do it component-wise. You can also add a constant, for instance, or multiply by a constant. And all these are features that do not really work on the HP48 or 49 or 40 or 50G. There are also the functions by default will apply component-wise on a vector. So if I enter 1, 2, 3, for instance, and let's do that with 2, 4, 6 for reasons that will be apparent. Now I apply 1 over x to this, and I get the operation applied to all members of the vector. And of course, there is a tools menu for vectors that has a quick entry for vector operations where you don't have to shift, you just hit F1. This is really a matrix menu because you can compute operations on matrices as well. But let me just compute first the norm of a vector like this. And I'm going to compute the norm like this. So if I want to enter a matrix, all I need to do is to use this twice. So once for the first level of the matrix, and then I'm going to enter all my components like this. And because I want a matrix that, well, let me start with this matrix here. So I can add two matrices like this, or I can, let me undo that. I can subtract, I can multiply square matrices, and I can compute the inverse. Now, this is where having exact computations will shine. If I compute the determinants here, I get exactly 0. Now, let me do that on a HP48, and let's see what it does. So on a HP48, I'm going to do the same principle, 1, 2, 3. 4, 5, 6, 7, 8, 9. Now I don't remember where. And you see that the determinant that I see with the HP48 is not exact. It gives me a non-zero determinant because the values are too big for it to be able to compute it accurately. So what is interesting is that I can actually do even symbolic operations like this. And I can invert that with 1 over x. Granted, this is not very readable, but it's correct. It's doing the correct computation. and I can apply this matrix. So let's edit the matrix and change it so that now I can invert it. Oh, let me try to invert it without doing that first. And because I can determine that the determinant is 0, I get a correct error message. Again, the HP48, if I do that, gives me a matrix with very large numbers in it. And if I edit it and I make it something that can be inverted, now if I compute the invert, I get also exact results with fractions. Now this is one case where I will not be able to use the same O trick to change it, because what this does is really change between various representations of the object. And so what I need in that case is to use the toNum function, which I find in the frac menu here, and I can convert it to a number or to a fraction. Now, of course, we have already seen that, but you can have complex numbers in matrices like this. And so if you edit that, you're going to see your values, and you can see the problem of precision that when you're not computing. So I was using decimal, and that's immediately hitting me with 001 that make it harder to understand. Okay, so we have seen matrix operations. We have seen quickly another object, but I'm going to make it explicit now. That's the list, and that's second shift on the eval rs key at the bottom, and that's essentially to store data. So the difference compared to vectors is that a list is not designed to be homogeneous. It's really designed as a bag of data. So if I add 3, it's not going to do, so let me compare with what I had with a vector. If I add 3 to a vector, that's what I get. I get a mathematical operation. If I add 3 to a list, that's really a bag, and I can have a list with a list with a list. Oops. A list with a list inside, and I can have some text in it. So this is really a general storage mechanism for data in RPL. And just like text, you can, for instance, add to lists, and you can also repeat a list. So this is really a powerful way to store arbitrary data. Okay, one thing that is really important for me as a software engineer is computations on based numbers. So let's say that I want to do some operation on hexadecimal numbers. Let me do that on the real machine so that you can see really how convenient this is. So I hit the base there, and I have this hash sign that lets me enter a number. And now the cursor changes to B, and that's one easy change to explain, is that now if I hit this key, I get A, B, C, D, E, F. So I'm directly entering hexadecimal numbers without having to shift or alpha anything. So that's really quick. And you can see that the separator shifts to 4. There is a separator number of separation for base numbers like this. So yes, that's because the base I'm using is binary. Oh, so am I stuck? No. I'm going to add. So I can do this the old HP way. I'm going to use a lowercase h as a suffix. And that's going to let me enter an hexadecimal number while I was in base 2. So let me shift to base 16. That's hex. And you see that the base number is displayed at the right. So back to the simulator for more examples. And so if I hit the simulator was in hex, so that's what confused me, is that the calculator was still in binary mode. So I can enter 1EFF, for instance, and I can do a NOT operation on this. And that's a 64-bit NOP. That's defined by the word size, which is here on F1. So the word size is 64-bit. If I really want to if I really want to work on a 16-bit processor, I can use 16 as a word size. And now if I do not on, I think I had one EFF, forgot what I had, but if I do not there, yes, that was it. And so now it's doing it on 16-bit. And I can do my operations, and they are going to perform on the largest number. So there is no data loss just because you have a word size. It's keeping the data, but if you're doing an operation like this, sorry, what I was trying to show is that the word size is in effect on the numbers you're entering there. So for instance, 1, 2, 3, 4, 5, 6, like this. I do not lose data despite being in a word size. But if I do an OR there, so that would be 3, now it's going to truncate it on 16-bit because the number that I had entered earlier was for a 16-bit computation. So it's the computations that truncate, not the data entry. So you can have data that is more than your word size, but as soon as you do a computation, then it's going to truncate it. Now, because we have large number support, I can also have a 256-bit processor. So 256 as my word size. And now if I do not, I got a result that is pretty large. And again, it's convenient to have a large display. Now, you have seen that I could use the 4 standard bases: binary, octal, decimal, and hexadecimal. But I can use arbitrary bases. So if I want to enter a number in base 3, let me go back to a more reasonable word size, like 64-bit, or actually even 32 would be better, so that I'm not overwhelmed, because I'm going to enter in base 3 now. And so if I enter, that won't work because digit 3 is not valid. So let me remove that. And now I have this number in base 3, and I can convert it to hexadecimal. Now, what if I want to enter a number in base 3 while I'm operating in hexadecimal? Then I can do this. And I got my result directly in the correct base. So there are many operations that are already implemented. You can see that it has the logical operations. It has and, or, XOR, etc. It also has planned shifts and rotations, but they are not there yet. By the way, you see that there is no next key on the DB48X, so I have to resort to using the F6 key when the menu is too big to get to the previous or next menu entry. Most built-in menus are designed to fit with at most 18 entries. If that doesn't fit, I tend to create submenus instead of having large menus. So another interesting thing is another use of the O key there, and the O key essentially shifts bases and also shifts back to having a decimal number. Now this behaves slightly differently depending on the version. You see that there it's changing the base for the display. It's likely in a future iteration that it will only change the number in the first level. Okay, one recent addition from 048 is units. They are not fully operational yet, but you can see how this works. So if I want to have 1 meter, for instance, and I can enter 3 kilometers, the problem is that the operations do not work yet, so I cannot perform an operation like a multiplication, for instance. So this is going to be for 049 or later. Implementing units correctly is relatively complicated, so it's going to take a bit of time. But the units objects themselves are there. Finally, this is a programmable calculator. So let's enter a program that computes a VAT. So for instance, in France, to add VAT, you add 20%. So this would be a program that does that. And if I want to use that program on a price like 100 euros, I have the program in my first level, and the values must be above it. So I need to swap there like this. And then I hit the RS key. So that's the key at the bottom here. That's triple roll, eval, equal, and space. We have seen that it does the equal equivalent for equations. For a program, it evaluates it like this. Now, I can use last args to recall my program. Oops. Actually not. Oh, that's an interesting bug. No, that's not a bug. That's last. That's a bug in the documentation, because the last args are updated while you run a program, but the undo is not. So let me do that 1.2 times. And if I evaluate that, so you saw that last arg would give me the result of the last operation, which was the multiply. But the undo stack, oops, gives me the last stack before running the program. So I can modify my program with the command line history. If the VAT was, let's say 19.6 like it was before, and I would get the result like that. But that's not really convenient, so it would be nice if instead I had the VAT and the program stored somewhere. And so let me store my program, the same one, but now I'm going to use, well, let me have a VAT rate first. So the VAT rate would be 20%, for instance. And I'm going to put that in a variable named VAT rate. So for that, I type the name with the equation key, and I type VAT rate. And then I hit the stow key. And the recall menu, what corresponds to the recall key here on the DM42 corresponds to the var menu, and you see my VAT rate variable there. If I hit F1, it's going to give me the name of the content of the variable. If I hit Shift F1, it's going to give me the content as well. We'll see the difference between the two. It's really recall. And if I hit a third time, it's going to update the variable, but for that I need a new value. So I know, for instance, 19.6, I would hit 1, and now my value is 19.6. So it's a shortcut for the stow operation. Now, back to 20, I can also, on the command line in a program, use this operation, and you see that it inserts the code for that, and I can evaluate that, and my variable now contains 20. So if I want to have a general VAT program now, it can use the VAT rate value and then add 1 and multiply by the input. And I'm going to call that predictably VAT and store. And now my menu is updated with the VAT function, and so I can now compute the VAT on an arbitrary value. Sorry. Oh, there is a bug. There is a bug, so I need to recall. So see that when I did that, 100, I expected to have 120. I hit F2 to evaluate the program, and I don't get the right result. So I need to recall my program. So now that's the difference between shift and not shifted value. If I do shift, I'll recall the value. And now I can edit it with the down key. And the VAT rate is in percent, so I need to divide it by 100 first. That's my problem. And now shift, stow, and I can run my program again. Now it does what I want. So you can see that there are really 3 operations on variables, and that when I use a program like this, I can simply use the name as is, and it evaluates the content of that variable. But that's true for programs as well. So that means that now I can have a program that applies the VAT twice. And to do that, all I need is something like this. And that's going to apply the program twice. So we call it VAT2, which is a very original name. And now if I do 100 and run VAT2, it applies it twice. So what I have done essentially is that I've created a new word to my RPL vocabulary. And that's one of the really incredible strength of RPL, is that you can extend it the way you want, and the words you add really behave like the built-in functions. That's really powerful. So there's one thing in what I said that might have surprised you if you come from the HP48, is that the HP48 actually has store and recall backwards compared. So for the var menu, if I do X, that evaluates the value. If I do this, it records the value. If I do that, it stores in the value. So let me store 4 in X, and I recall X. So this is backwards. The shifts are backwards compared to what is in DB48X. Now that's intentional. The rationale for that is that storing is a dangerous operation. So it's better to have 2 shifts for storing inside the variable. So you have seen that when I was looking at my program, I could use the name as is like this. But if I do this, I see VAT recall. What happens if I don't? I keep the quotes like this. So what happens? Let me store that in VAT2. I don't need the VAT2 anymore. And I run that. So, I think I must have kill it twice, something like that. I don't understand this result. Let me see. Oh, uh-oh, I think I stored in the wrong variable. I hit the wrong key. Yes, I started in VAT. So let me execute VAT instead of VAT2. And you see that now it's doing the operation in a symbolic way because I use the quote. So the quote is a way to not evaluate a variable. That's essentially preserving it from evaluation. And now you have something that you can evaluate with equal. Oh, I started in VAT. That's the bug. Sorry. Okay, so let me recode that. Let me recode that program and store it in VAT2. And okay. The problem is that the variable is called VAT rate and not VAT. That's what I wanted to do. So now I store that in VAT2. And let me recall VAT1 and put that back to VAT rate. Okay. So now this is without, VAT is without quotes and VAT2 is with quotes. And now we can check that again. So VAT like this computes, VAT2 computes a symbolic value, but then I can hit equal and get the same result. That's what I wanted to demo. Okay, now that state is very precious, so I may want to save this. So I go to Setup, State, Save State, and then I'm going to name it as VAT, for instance. And now my state is VAT, and I can restore that later, including other values of variables. Now, once I have a state entered like this, let's say that now my VAT rate changes, and it comes back to a more reasonable 19.6, which is, when you think about it, it's really super decent. And I can save my state very quickly by hitting second shift exit. So that's save. And now my state, including the value of all variables, is on disk. That's a pretty long demo already. Let me do one last thing, which is I'm going to do, so to show some symbolic operations, like I do sine of x like this, and I multiply it by cos of x. So I can build an expression like this. Let me just add some factors here to make it nicer. So when I'm inside an equation like this, another hit to the F key gives me parentheses. And so I can do something like this. Uh, I'm computing in degrees, so I'm going to keep it like this. And now I go to the plot menu. So that's they are not connected. Uh, so larger values. So this is how you can plot a function very quickly. Let me edit that and to the larger value in there. So you can really quickly plot values like this, and you can do that in polar form as well. So not very visible, so oops. I need the history there. And interesting, why did that? So you can do a variety of plots like this relatively quickly and interactively without even programming or anything. The scaling is done the same way with the p-power variable as under HPK48 with the same meaning, except that the functions to scale it interactively are not there yet. This is going to be added. You can draw things with a line width, for instance. Oops. Sorry. Line width, like this. Oops. I'm getting tired, sorry. So I have a line width of 3, and now if I up, no, that's not the one I want. I don't know if this will plot correctly or not. We'll see. It was not very nice looking. There is a minus of the same thing, so it's not going to look very good. What does my expression look like now? I need to remove that, and okay, I'm getting too tired for that, sorry. Well, okay, that looks more interesting. So you can see that the line width is applied. That's the interesting thing. There's a a numerical solver as well. So let me solve, for instance, x to the power 3 equals 2. And I will solve that for x with a starting value of 0. And now I'm going to use the solve menu. That's the root function that gives me the cubic root of 3 that of 2 that we can compute that way as well. So you can write, as you saw, an equation in the form a equals b, and that's recognized directly as being an equation. Finally, I can do numerical integration as well. So for instance, I can do between 2 and 22. I can integrate x, the inverse of x, x minus 1, for variable x. And if I compare that to log of 22 minus log of 2, and I get the same value. So it's doing the numerical integration as well. And if I subtract the 2, there is a small error because it's redoing another operation. Okay, I think that's about it for today's demo. I'm too tired and I'm making many mistakes, and it's very long anyway.